Welcome back to the second half of today's lecture, everybody. Today we're going to be looking at, in this portion, we're going to be looking at things that build up from your atoms and your elements. So if you think of elements as the basic building blocks, the Lego pieces, a compound is what you get when you start putting those Lego pieces together. And so a compound is one or more elements that have been chemically bonded, and we'll talk about chemical bonds here. Compounds that are common include things like water, carbon dioxide, the hydrocarbons that make up just about everything in your body. Between hydrocarbons and H2O, water molecules, that majority of your mass, almost 99%, is going to be just those two compounds in some variant, right? Hydrocarbons come in a wide variety, and we'll look at that later in this unit, or this chapter, actually, this module. But the idea here is that compounds are what make up most of the matter that you see. You very rarely see elements in their pure elemental form. They almost always exist as some kind of compound with another element. Now, again, compounds such as water are formed when two or more elements combine, and so two hydrogen atoms combine with an oxygen atom to make H2O, that's water. The force that bonds a compound together is called a chemical bond, and it comes in two types, and we're going to look at that. And electrons travel around each of your atoms and then get shared or stolen in some cases. That allows for the chemical bonds to occur. And atoms become more stable when their electron count gets closer to 8. It's known as the octet rule. And again, in chemistry, we would look at that in a lot more detail. It's not a universal truth, but usually, and that's one of the hard things about chemistry as opposed to mathematics, is that it has things that it calls rules, like the octet rule, that are true except when they're not. So again, when we look at chemistry, we can talk about that later. So in atoms that share electrons, you get what's called a covalent bond. But the first type of bond the book talks about, sorry, I jumped the shark there, is an ionic bond. And so what happens with an ionic bond is you have an atom that has loosely held electrons like a metal. And then you have atoms that are near to getting a full octet, say like halogens. That's a non-metal. They're usually gases. And the halogen will steal an electron from the metal, making the metal have a positive charge because there's an imbalance between protons and electrons, protons being positive, electrons being negative. So the metal gets a positive charge, we'll say lithium, which is a metal, gets a +1 charge because it loses an electron to fluorine, which is a halogen. Fluorine gets 8 electrons. It had 7 to begin with because it has a multiple of 7 valence electrons, or outermost electrons. It gets 8, it gets its octet, but it also gets a negative charge because it stole an electron. And so a positive charge attracted to a negative charge is what you get when you get an ionic bond. Now in covalent bonds, which I was trying to jump to a little too early, you have the sharing of electrons, okay? And so again, if you think of electrons as like clouds of these small things that move really, really fast in patterns called orbitals, well, when two atoms that have similar attractions to their electrons come into contact, if they come into contact with enough force, their clouds can start overlapping, the clouds of electrons, and they can start sharing electrons, right? So oxygen, for example, has 6 outer electrons. It wants to get up to 8 to make it more stable, because that's the rule. Again, there's many exceptions, but we don't need to know that for now. And when two oxygen atoms bounce together, each one will share two electrons. So it's like each one having an extra two electrons. That gets both a 6 up to 8. And so you get a double covalent bond. And covalent bonds, which is the sharing of electrons, can get up to a triple bond. So two carbon molecules, which have 4 valence electrons, can share up to 3 each. So that's 6 total, and then one extra for it is 7. And it'll need to bond with something else to become stable. But it can form a triple bond, and that's what that's called. It's called a triple bond, where each one is sharing 3 electrons, and so each one acts like it now has an extra 3 electrons to what it originally had. Nitrogen also can form triple bonds. Now, hydrogen, that only has 1 valence electron, can only form a single covalent bond, or it can form an ionic bond to a nonmetal. It's one of the only gases that can behave kind of like a metal, so it's a little bit of a special case. But the idea here that I'm trying to get across, and I'm probably saying too much because I also teach chemistry, is that through the sharing of electrons, you can form a covalent bond. All right, and that brings me back to our question, our focus question: what makes up everything around us? Well, hopefully I have just given you some ideas of great things that make stuff up around us. And if you have questions, of course, please ask me. I love questions. I think they are, in fact, the best. Thank you so much for listening.